Okay, guys, welcome back. I'm going to assume that you just watched the conversions video on how to convert any of the bases to base 10. I want you to take note that we use the exact same method to do all of them because we're going to keep this simple. If we want to go to base 10, we use the method we just looked at. If we want to go from base 10 to any of the other bases, we're going to use one method, because we want to keep this simple. We're only looking at the first question on the UL exam. We don't want to convolute this. We have 40 other questions to worry about on this test. So we don't want to get too crazy with this question one. We want to keep it simple so we can get through it pretty quickly. So here's how we're going to do this. We're going to pick a number here. So we're going to pick, we're going to pick 175. Now let me point this out. So if you go to Google and you Google hex, binary, decimal converter, or something like that, there's calculators out there that you can use to convert any number to any base automatically. I'd advise you, if you want to practice this, go look up one of those calculators and just start picking some random numbers and converting them. You don't really need my practice sheets that I sent out. Um, you can come up with a random number and just convert it, and then you can check yourself on one of those calculators. So I would definitely advise you to do that. I've already done that with this number 175. I went and found a calculator, put in 175, and checked myself to make sure I did it correctly. So definitely go do that. It's something useful to have. So what we're going to do, we're going to convert this 175 to all three of these bases because I want to show you that you can use the same method to do all of them. Now, I may mess up somewhere in here, so just forgive me. I mean, I'm only human, and I'm doing this, off the top of my head. So here we go. So what I'm going to do is I'm going to do base 2 first. This is how we're going to set this up. I know this looks like an upside down division. It's going to make sense why we do this in a minute. Um, this is how ONCS does it. I like it. It's really simple. And it does kind of symbolize division because I am going to do a lot of division here. What I'm going to do, this is my base 10 number. So this is how this would look on the exam, 175 base 10. And I want to convert it to base 2. So I'm going to put a 2 out here. I'm going to divide this number by 2 over and over and over and over again until I can't divide it anymore. All right. So when I first divide 175 by 2, okay, if I come up here, say in the margins somewhere, and I do that, 17 divided by 2, that's going to give me an 8. 2 into 15, it's going to give me a 7. Sorry, I know that looks horrible. With a remainder of a 1. Okay, so here's how I'm going to write this. 2 will go into 175 87 times with 1 left over. I'm going to keep a tally of all my remainders I get over here on the right-hand side. And that's important, and it's going to make sense once I make it to the end, okay, because we're going to use those remainders. Okay, I'm going to keep going. I'm going to keep dividing these numbers by 2 over and over again until I can't do it anymore. 87 divided by 2, I believe that's going to be a 43. 43 times 2 is an 86. So yes, that's right. With a 1 as a remainder. Okay. 43 times 2 is 86. I have 1 left over. It's my remainder. So now I'm going to do 43 divided by 2. That's going to be a 21, I believe. It's 21 times 2 is 42. So I have another remainder of 1. I'm going to do it again. 21 divided by 2 is going to be a 10. 10 times 2 is 20. I still have 1 remainder. Okay. Now watch this. We finally made it to an even number here. These were all odd numbers. I'm at an even number. Watch what happens. and it's, like it's something crazy, but 10 divided by 2 is even, a 5, with no remainder. That's important. Now I got a 0 out here. Okay, 2 into 5, 2 times. I have a 1 as a remainder. Last time, 2 into 2, 1 time. 1 time with no remainder. Okay. Is there an easier way? Let me go ahead and write this out. So here's what we have. You'll notice I have all these 1s and 0s. You might have made the connection that, yes, that is my answer. Out there as there was remainders. And I wrote it backwards. I told you I was going to mess up somewhere. I wrote it backwards. We're going to start at the bottom. 1 0 1 0 1 1 1 1. The reason I messed up is this is not how I would do this. But I want to make the connection, like I said, that we can use this method to do any of these. And given this is a pretty big number, but this is a very simple method that we can always use to get this answer. This 175 base 10 is equal to 10101111 base 2. Okay. I'll come back later and show you a different method to do this. Don't want to do that right now because like I said, I want to make the connection that we can use this same method with all of these. So I want to put them side by side, essentially. There we go. Let's do base 8. Hopefully I have enough room here. Base 8. Okay. So let me come up here, kind of the margins here in the blank space. Set this up. Okay. 8 to 17 is a 2. 8 into 15 is a 1. So 21 times with a remainder of 7. Okay. All right. I'm going to do it again. 8 into 21. You're going to notice this one's a whole lot easier because I got a bigger number to divide by instead of 2. So 8 into 21. It's going to go 2 times. That's 16. 8 times 2 is 16. That leaves me a remainder of 5. Okay. I'm going to go ahead and erase this math over here. Make myself some room. Okay. Now, can 8 go into 2? No, it cannot. So I'm done. This is it. I can't divide 8 into 2. Just like over here, I couldn't divide 2 into 1. So I stopped. I was at the end. I'm at the end. Now recall back over here my answer. I went from bottom up. 1 0 1 0 1 1 1 1. Okay. Same thing here. I'm going to go bottom up. 2 5 7. I just converted 175 to base 8. 175 base 10 or decimal is 257 base 8. And I use the exact same method. Let's keep rocking and let's try base 16. All right. Now we got to keep in mind, we got to remember. Gosh, was this the same number I used a second ago? So you probably already know the answer. Anyway, we have to remember our hexadecimal digits 0 through 9. And then we go to A through F. So 0 through 9, 10, 11, 12, 13, 14, 15. We have to remember that. So let's put 16 into 175. I'm going to find some space out here and let's do that. It's going to go 1 time and it won't go into 15. So what we got is, sorry, my bad. So what we've got here is 16 into 17 is going to go one time, one left over. Let's put just a second. Sorry about that. I had some video issues. Okay, so what we've got here, keep rocking. Okay, so 16 into 175 is we're going to go 10 times with 15 left over. So what we're going to have here is a 10 with a remainder of a 15. Get this out of the way. Okay, so 10 times 16 is 160, and we've got a remainder of 15. Okay, now can we put 16 into 10? We cannot. So we're done. Notice how this got a lot easier. The bigger that number got, that base got, the easier it got to convert. But yes, we have to remember that we do not have a 10 or a 15. So we've got a 10 and a 15. We do not have a 10 and a 15 in hex. What is a 10? Well, the 10 is the A, and the 15 is the F. So all we do is we convert these. That 10 is an A, and that 15 is an F. And there we go. 175 base 10 is AF base 16. 257 base 8. 1010111 base 2.